students, let us continue the lesson gravitation. Okay, so from previous class onwards, from previous two classes onwards, we are discussing the problems on gravitation, right? Okay, so from yesterday's class onwards, we are discussing problems in your textbook application of concepts. Okay, so let us continue the fifth problem today. So find the free fall acceleration of an object on the surface of the moon if the radius of the moon and its mass are 1740 kilometers and 7.4 into 10 to the power of 10 to 2 kgs respectively, and compare this value with the free fall acceleration of the body on the surface of the earth. Okay, so we already derived this formula of free fall acceleration, and also we found the free fall acceleration of moon and even earth, and we compared even. Okay, so gravity on the earth is 6 times more than the gravity on moon. We already discussed this. Okay, let us once recall this. Okay, see see, this is a formula. G is equal to, okay, small g is equal to capital G m by r square. Okay, so if you want to find the gravity free fall acceleration of earth, we have to place the mass of the earth and radius of the earth. Okay, so we already calculated these, and so free fall acceleration on the earth we got a 9.8 meter per second. Yes or no? So and even the free fall acceleration of the moon also we find, that is we got a 1.62 meter per second square. Okay, so CG free fall acceleration on the earth is 9.1 meter per second square. So we compared and we got 1 by 6th, that is gravity or free fall acceleration on the earth is greater than moon. Okay, that is gravity on the earth is 6 times more than the gravity on the moon. Okay, so this calculation, let us check the previous third video. Okay, from the last see, concept wise we discussed last concept video. So from previous two classes onwards we are discussing problem, right? Before that video, just refer for this calculation. Okay, so nothing is there here, just we need to substitute the values of moon and earth. Okay, so capital G m by r square. Okay, so here G is the universal gravitational constant, G value 6.7 into 10 to the power of minus 11. Okay, Newton meter square per kg square. Okay, and mass here, while calculating the free fall acceleration of earth, we need to place the mass of the earth. Okay, mass. Okay, so next radius. Okay, if the moon, we are calculating for the moon, then substitute the radius of the moon, and if the mass moon, okay, then you will get the this value. So G of moon we got how much? 1.62 meter per second square, and G on earth is equal to 9.8 meter per second square. So G on earth is greater than G on moon. Okay, so how much greater? 6 times more. Okay, on earth. Yes or no? Clear? So let us see the next problem. See the next problem. A ball is dropped from a height. If it is takes 0.2 seconds to cross the last 6 meters before hitting the ground, find the height from which it is dropped. Okay, so what he is telling, suppose let us consider he is dropping a ball from here. Okay, so it is touching the ground, but it is taking 0.2 seconds before hitting the 6 minutes before hitting the 6 meters before hitting the ground. Okay, 2 seconds it is taking for this. Okay, so what we need to find here, before dropping, initial velocity is equal to 0, right? Okay, so initial velocity 0. Okay, and let us consider this total height be h. Okay, so this total height h. So let us find the total distance, this h we need to find. So before calculating these h, so let us find the these 6 meters 0.2 seconds, right? Yes or no? So final velocity before this, here we need to find the velocity, that is u. Let us consider final velocity. I'm taking u. This u we need to find. Okay, so what is the formula? So we know the distance formula, right? Yes or no? So what is the distance formula? S is equal to ut plus of a t square. In place of a we need to take a g value, that is 10, right, meter per second. So here initial velocity 0, right? Okay, so 0 into time 0.2 seconds plus half into a is nothing but 10 here, t 0.2 whole square. Okay, so 0 into 0.2 0 and plus half into here 10 into 0.04. Okay, so if you 2 ones are 2 5s, so if we calculate you will get 29 meter per second square. Okay, see, sorry, here we have to take a final velocity. Okay, so this before hitting the ground we are taking final. See, we are finding the see, we are finding here u, right? U means here final velocity. In here final velocity is nothing but it's not 0, so let us take it as u. Okay, so u means 0.2 u, here 0.2 u, and this is, and x distance given already 6 is equal to 0.2 u plus 5 into 0.04. Okay, if you calculate u here you will get u is equal to 29 meter per second. Okay, so u is equal to 29 meter per second you will get. So this is a u value. So now see, let us find the h. Okay, so before finding h we need to find the distance, h only, distance, right? So you know final velocity here u, and initial velocity 0. So let us apply the formula, that is last formula, v square is equal to u square plus 2as. So here v square nothing but final velocity, right? Before it is before hitting the ground it takes 0.2 seconds, he said, no? So here we found the u value, right? U value 29 meter per second, right? So this I am applying. So here final velocity 29 whole square, that is equal to see, initial velocity 0 plus 2 into 10 into s. Okay, so here 29 into 29 by 20, that is equal to s. So here s you will get 42 meters. Okay, so this s is nothing but here this distance. Okay, this distance is 42 meters. So he is asked, has to find the total h, right? So h is equal to s plus 6, that is equal to 42 meters plus 6 meters, that is equal to 48 meters. So the bob of a simple pendulum of length 1 meter has mass 100 grams and speed of 1.4 meter per second. At the lowest point in its path, find the tension in the string at this moment. Okay, so see, this pendulum is suspended like this, and it will make a to and fro motion, right? Okay, so while making its to and fro motion, you feel that it is making a see, you can see that it's making a round, means circular, it's moving in a circular path of length l, that is if we can take that is as a radius of the circle. Okay, so what happens, always tension acts in the opposite direction to the gravitational force, and here so that mj acts in the downward direction. And also let us take you are sitting on the simple pendulum bob. Okay, so you feel a force, that is equal to m v square by l. Okay, so you feel this force in the downward direction. So what happens, but if you can feel the that you are at a constant with respect to the rotation of this bob. Okay, you are constant, so means you are in a equilibrium state. So if you are in equilibrium state, so always in equilibrium state, what happens, so all the um, forces are balanced, right? So that is equal to tension is equal to what happens, mg plus m v square by l. Okay, so you can take mg plus, means tension is balanced with these two forces. Okay, so what is the mass of the bulb? 100 grams given. I am converting this into kgs, so I am dividing with the 1000 into 10 plus, again here mass of the bulb 100 by 1000 kgs into 1.4 whole square here. So how much will get here? Here 1 plus 1 by 10 into 1.96 here you will get. So that is equal to 1 plus 0.196, that is equal to 1.2 newtons. Okay, so this is the tension acts on this simple pendulum. Okay, so here see, so in equilibrium, if you observe this pendulum, it will, you can see it is in a constant position, means it is in equilibrium. So in equilibrium all the forces are balanced, so that is tension is equal to mg. These two forces are acting, right? So always opposite to the tension mg will act. And also so let us, you can feel the mv square by L force in the downward direction. So tension is balanced with these two forces. Okay, T is equal to mg plus mv square by L. So here 100 grams given, I am converting into kgs. 100 grams by 1000 into 10. So you can calculate that tension is equal to 1.2 newtons. Okay, so let us take one more problem. A stone is released from the top of a tower of height 19.6 meters. Calculate its final velocity. So these are the other examples I am taking. Okay, so what happens here, a stone is released from the top of a tower of height 19.6 meters. Calculate its final velocity. Okay, so what is the formula here? So if the stone is released from the top, right? So if it is releasing from the top, means initial velocity is 0. Okay, 19.6 meters and initial velocity 0, and a distance given s. Okay, so here initial velocity is 0 and s is equal to 19.6 meters. He is asking us to find final velocity, that v. So and we need to take a g is equal to 10 meter per second, or let us take 9.8 meter per second square. So with these three terms you can see the third formula, right? Yes or no? So v square minus u square is equal to 2as. So v square, here we need to find v square minus 0 square, that is equal to 2 into 9.8 into this s value 19.6. Okay, so this v square is equal to here 2 into 9.8, that is equal to how much you will get? 19.6 into 19.6. So here I am removing the point and I am keeping 9.6 by 10 into 196 by 10. So if I remove this square, I'll get a root, right? So I'll get the value 10, that is equal to 19.6 meter per second. This is the final velocity. Okay, so let us see one more problem. Okay, see, calculate the force of gravitation. Okay, so calculate the force of gravitation between the sun and the earth, given that mass of the earth is 6 into 10 to the power 24 kgs and of sun is 12 into 10 to the power 30 kgs, and average distance between them is 1.5 into 10 to the power 11 meters. Okay, so here what are the given terms here? Mass of earth. Okay, so mass of earth is equal to how much he given? 6 into 10 to the power of 24 kg. Okay, and mass of sun. Okay, mass of sun is equal to 2 into 10 to the power of 30 kg. And distance between them. Okay, distance is equal to 1.5 into 10 to the power of 11 meters. And you know universal gravitational constant, that is G is equal to 6.7 into 10 to the power of minus 11 Newton meter square per kg square. Okay, so let us apply the formula. F is equal to G into m1 into m2 by d square. Okay, so here 6.7 into 10 to the power of minus 11 into sun mass is equal to, or earth mass, 10 into 10 to the power of 24 kg. Let us write units later. And next 2 into 10 to the power of 30. Here kg square you will get, and that is kg square cancelled, and distance square, that is 1.5 into 10 to the power of 11 into 1.5 into 10 to the power of 11 meter square you will get. Meter square cancel. What is the left unit here? Newton only. So let us write the numericals once in one bracket, and these 10 powers in one bracket. 6.7 into 6 into 2 by 1.5 into 1.5. 1.5 into 1.5. In the next bracket, 10 power minus 11 into 10 power 24 into 10 power 30 by 10 power 22. Okay, so here if you calculate these numericals, here you will get 35 into 57. Okay, so into 10 to the power of minus 11 plus 24 plus 30 minus 22. Okay, so these if you calculate these two, you will get plus 2. 32 minus 11, how much you will get? 21. 35.57 into 10 to the power of 21 newtons. If you round figure this value, you will get 335.6 into 10 to the power of 21 newtons. This is the force of attraction between sun and earth. Okay, so like this you will solve the problems, and the problem part is very important. In tomorrow's homework also you will get the problems. Try to solve the problems. So from Monday onwards I will discuss the problems of motion. Okay, so motion lesson after 25th you have exams, right? So for that we let us consider this is a revision class. From Monday we discuss the problems of motion, more and more problems. Okay, so try to solve the problems of motion, textbook backside, that is application of concept problems. Try to solve. If you have any doubt, you can text me. Okay, so if you miss any video, go to my YouTube channel and try to search for the particular video. You can find a playlist and don't miss any video. If you miss, you can take the and you can listen to the video or particular lesson in my Facebook channel, that is Anu Techie. Okay, thank you.